Hello everyone and welcome back to the multiverse of 100 plus data science project series. In this video, I am going to discussing about the Indian coin detections as well as the count of the coins using Yolov10. So let's have a look at the demo application first. So this is the demo application. So you can also drag the images from your directory as well as you can click here and it will open your file explorer and you can select the images from here. So let's select this one and click on open. And if I click here to submit, but before that let's try to load it and click on submit, and inside the sections you can see here annotated images, how the image is look like and how the detections. Also you can see one, the five with having the confidence score 1 5 2 10 1 2 2 1, and also you can see here detection count 5 rupees is not by 2, I mean 5 ka sikka hai 2. So if I check this one, you 1 and the 2, then 1 for 4, 1, 2, 3, and the 4. Yeah, then after the 10 for the 1 and 2 for the 3. 1, 2, then yeah, here you go. So total count is nothing but 30 rupees. So this is how the application is look like and how it will actually work. Now in this tutorial, we're simply going to building this one. So बिना किसी डर के हर हर महादेव बल के start करते tutorial. Well, so this is the official GitHub repository for the Yolov10. And if I go down, then you can see here one metrics based on the performance of the Yolov version that is recently updated. So recent update is nothing but Yolov10. And in this graph, it has started from the Yolov 6. And if I go down, you can also see here they upload their model in the Hugging Face, as well as you can also read their research paper. And if I go down, then you can see here it having a cerebral model, just like Yolov10N, the S, the M, the B, L, and X. You can use any of them, and you can see here test size are both are same, and how many parameter actually use it inside this pre-trained model, and also the latency, how many times, how many millisecond it will take for the each of the data. So they actually use here the Coco dataset for detecting the objects. So this is the patent model. So we are simply going to cut the patent one and try to give our custom object, okay, for training it. Okay, so now what I'm gonna do, I am simply go on my Google Colab. You can also use here your Jupyter notebook or your own laptop. But here the condition that you have the Python version should be greater than 3.8, and also you have the PyTorch in your local machine up to 1.8, and also Coda. So this is the data set you're going to be using here for building our custom object detection model. It is from the RubyFlow. So you can also take the images of your rupees or the coins by own, and also using here the labelme.exe file for annotations. And if I go inside these images, and you can see here there are so many images are available, and it also divided into train, test, and also the validations. And if I go inside these dataset sections, then you can see this is the version number 1. You can download all of the format in the dataset, and you can see how many images inside this training set, how many images for the validation set, and also the testing set. And now if I go inside the overview again, and if I go down, and you can see inside this URL sections, there is a link, okay, and also you can see here the project name and also the workspace name. So based on that, we can calling it using the API. So for getting the API, just need to go on that and create an account on that, and after that you can get the your API key inside your workspace. So this is my workspace, and you can see here my API key is right there. So just you need to go on that and create an account on that, and after that you can get here your API. And simply you're going to using this API in our Google Colab so that we can get in the dataset directly from the RubyFlow. Well, so I just go on the Google Colab website and also creating here an empty IPMD file. And now I need to click on the runtime and change runtime type should be in the form of GPU, and click on save. Now you in the sections you can see here it will try to connecting here the new runtime. Let's click on here to connecting with. So our GPU is connected, and you can see T4 GPU is connected to Python 3 Google Compute Engines. So let's click here to open this one, and these sections our all of the model file and all of the output should be stored. So now what I'm gonna do, I am simply go on the official GitHub repository for the Yolov10. So let's go on here. Here you go. You can see this is the official GitHub repository for the Yolov10. So I'm simply going to click here inside this code sections and click here to copy URL to clipboard. Fine. Now I'm simply go on here and start installing all of the dependency which one required for the Yolov10. So for that I can using here the same thing called pip install. Let's say -q, and inside that I can using here the git plus and simply going to pasting here the link. So pip install q. This is nothing but creating one folder that's called dash q, and inside that I am simply going to passing here my git plus my link. I mean link for my GitHub repository for the Yolov10s, and simply I'm going to using here the shift enter. Otherwise, you can also using here this button for installing all of the dependency. So it is installing just like the Ultralytics library and also the PyTorch in your runtime. Okay. So now what I'm gonna do, I need to also installing after installing that, I need to also downloading my model file. So what kind of model we're going to using it here? If I go the GitHub repository again, and you can see this is the GitHub repository, and inside this section you can see here models. So you can using here this model, any kind of model you can actually use it here. So let's checking this N1, and your job is to doing it using the X or the M, whatever. You can also use this one. Okay. Now what I'm gonna do, I'm simply go on here, and after that I can using here wget, because I need to downloading it and store it inside a folder. See, we actually installing all the dependency inside my Q folder. So that's why I'm simply going to download it inside my Q folder also. That's a P and the Q inside this Q folder. And after that, I need to giving here the link of that. So that's my link. I copy it here. So I'm simply going to copy these ones. And after that, I can paste it here. So what it can do, it will just go on this website and try to downloading this Yolov10 and .pt model inside this Q folder. So using here the shift enter, and after that you can see it will downloading this model file, the patent model file from that. And if I refresh this one, then you can see inside this Q section folder, you can see here our model file is available. That's called a Yolov10 and .pt. The model file is available. Now it's time to downloading our dataset. Okay, but before download the dataset, you need to also installing the library, just like the RuboFlow, because you're going to getting the data using the RuboFlow. You can also do it manually as well as. So let's say pip install. So pip install, we can using here the Q, because in the same environment, I mean the same environment, just like it's coming out, let's say environment, and inside this environment we're simply going to installing all of the dependency. Okay, so let's say RuboFlow. Okay, it will also installing this one that's called the RuboFlow. Well, so now what I can do is simply going to using here from RuboFlow. I am simply going to importing here the RuboFlow. Okay, that's it. Okay, our RuboFlow is imported. Now what I can do is simply going to creating one instance for that. So let's say RuboFlow, and inside that you need to giving here your API key. Okay, so let's say this called the RF. So it's free to use. You can use this API key as free. You don't need to pay anything else here. Okay, now after that I can using here RF dot workspace. So workspace, and after that inside this workspace I need to giving here my workspace name. If I go inside that, just to wait, and you can see this is nothing but my workspace name. So what I can do, I simply going to copy this one, and after that I can simply going to paste it here. Okay, and inside that I am simply going to paste it here. Okay, yeah, I need to paste it inside the quotations, so this one. And after that I need to take in a project one. So let's say give here project, and after that I am simply going to giving here this Indian coin is QBRX. Simply going to cut it, and I am simply going to paste it here. Yeah, you can also do it your own, just like you taking one coin and take out the picture of that, and just you need to go on the label me website, or otherwise labelme.exe file, and you can label it, and you can also upload it inside the RuboFlow. Otherwise you can also using here your Google Drive to uploading your data set. Okay, so now what I can do, I am simply going to make it, this is nothing but my projects. Okay, this is nothing but a project, so let's make it project. Okay, project. Yeah, now what I can do, we need to take in the version. So which version is available for that? The first version is available. Okay, version is nothing but my one. Okay, project, yeah, fine. So this is my version, so let's say version. Now my work is to actually downloading this data set called version dot download. Let's download the Yolov B8 one, because Yolov B8 version is available right now, and Yolov B10 is right on the new. In the next tutorial, we are trying to also using the Yolov B10s and creating one object detection model, custom observation model, and try to creating one application just like the Android and iOS applications using Flutter or the Android Studio, whatever. Okay. So what you can do is simply going to store it inside the dataset. Dataset. Yeah. Yeah, it's not actually running because I'm also giving here my API key. So let's give it out because I am not going to show you. So that's my API key. I'm simply going to click here to copy that. So well, I gave here my API key as well as I run the shell. And now you can see here they actually download the dataset of the version number 1 as well as they extracting the dataset in the after the div2 normal dataset, right? And if I refresh it, and you can see Indian coin 1 is actually downloaded on these sections. Now we simply go into using this dataset for training the model. But before that, I have to go on here and go on this data.yml folder, not a folder, actually file, and just I need to do some changes on that. So what I can do, I need to go on the test and I have to copy this one's copy path, and I'm simply going to paste it here. Let's say paste it, and let's do the same thing for head, and here you go. Yeah, just need to changing this one. It should be the train because path is always same. You can also go on here and just click on here and create actually copy the path. So let's say this should be the ballot. I hope so. Yeah, that's the ballot. So I am simply going to save it, and also you can see inside this YML file how the structure actually look like. It having one thing called names, and inside this name it have 1, 10, 2, 5. I mean 5 rupee, 2 rupee, 10 rupee, and the 1 rupees. The number of classes is nothing but the 4, and also you have the license or project or URL, whatever. Okay, so I'm simply going to closing this one. Now our thing is ready, so now we can start the training part here. Simple and easy. Simple and easy. But if you are doing this manually, just like taking the pictures using phone or camera and do the labeling job, so yeah, it will really taking time. Okay, so now what I can do is simply going to using here the yellow, and after that I can using here tux is nothing but my detect. Tux is nothing but detect. That's what you can see Indian coin count underscore detections. So let's make it detect, and mode is nothing but train mode. Yeah, and now what I can do, need to also giving here the epochs. So epochs is nothing but how many forward propagations and how many backward propagations should be happens, because ULU itself is nothing but one deep learning technique or the form of the neural network. So that's why epochs into giving here are the epochs. Okay, so epochs mean what? Epochs mean one forward pass and one backward pass. Now let's making the batch size, and that's mean how many a batch of the images should be coming up here. So that's why I need to giving here the batch size, images of the data, whatever you can say. So batch equal 32, and after that if you want to float, so let's making the float should be true, and let's taking this one so that we can go right after, and then we can giving here, we need to giving here the model. So our model is nothing but this one. Copy the path, and I'm simply going to paste it here. Yeah, that's our model. And after that what I can do is simply going to taking this same thing again, and after that I can using here the data is nothing but my that's my data. Just to avoid, that's my data. Copy this one, and after that I'm simply going to paste it here. Yeah, so that's my data and that's my model. You can see model is nothing but Yolov10 and .pt, and that's my epoch size and that's my batch size. And if you want to do the float for the training part, you can also making your float should be true. Okay, so let's use the shift enter, and now you can see it will download this. Yeah, it's already downloaded. Now it will start the training part, but before that it also initialize here the parameter, just like the uh, optimizers, or just like how many layers should be, output layer, input layer, how many classes. uh, that's all of the thing. It will actually imported all of the things, and it will also checking for the ultralytics also. Now you can see here it will also starting the training part, and you can see Adam W. This is the optimizers, and this is learning rate 0.00125. The momentum is 0.9 with the parameters group of 95 weight decay is nothing but 0.0. Oh yeah, they're actually using here also blurring technique, just like blur, median blur, the blur limit. They're actually using all of the things on here, the ULU B10s. Okay, so what you can do now, yeah, we need to waiting for few minutes for the training part, because yeah, it's starting. Now you can see epoch is starting. So I'll write back after how and the epoch is done, because you need to also do the validations as well as you need to creating the applications also. So let's waiting for that. Well, so our model training is completed. So now what we're going to do is simply going to testing it out in our validation data set. So for that, you need to also import here the ultralytics. So let's say from ultralytics, I'm simply going to import in here the Yolov10. Yeah, that should be the capital. The YOLO should be the capital and B should be a small and 10. Now what I can do, I am simply going to creating here one instance of the Yolov10, and inside that I need to give in here my model path. So my model path is saved inside this run detect train. So just I need to go on here, run detect, then we have train, and inside that we have the weight. So just copy this path so we can paste it just like that. Okay, so that's our model file and that's our model. Okay, so our model is ready right now. Now what I can do is simply going to give here my model, and inside that I'm giving here my source. So we're simply going to testing it out for our validation data set. So what I can do is to go on here, and inside this validation sections I'm going to copy this path, copy path, and I can give it like that. That's my source, and after that I'm giving him my confidence. So let's say conf equal to 0.25 confidence score, and let's say making the save equal to 2 so that it can save and we can also show it just like the plot using the matplotlib. Well, and you can see here, those are the images. Is try to predicting this one and try to also creating here the bounding boxes as well. Now, yeah, it's also save it inside the folder called the predict. Now inside this folder, we can simply go into iterate through and try to getting it by the locations and plot it using the matplotlib. So for that, I can importing here the globe for taking the images and also importing here the matplotlib dot pyplot as plt. Okay, then after that I need to also importing here the images. So for matplotlib dot image as np image. Okay, that's nothing but my for the np images. So now let's say images equal to globe dot globe. So why are you going to taking it out? We're going to taking out inside my run folder, and you have the detect, then the predicted, copy the path, and after that we can paste it here. And now we simply going to insert this predict folder. We're going to taking all of the images with extension is nothing but jpg. Okay, and we are going to taking all of the images from here. Now let's say discuss declare one variable that is help us to show that how many images should be displayed. So let's say you're going to display here, let's say 10 images. Okay, 10 images just mean we have the 5 columns and 2 row. Okay, you can also give it here 20 if you want to show the 20 images. So let's say we have the 4 row and the 5 column as well as this. You can also using here the 20. Let's make it 10 now. Then after that I need to creating here my subplot. So let's figure my axis is nothing but coming from my subplots. That's why I'll by default already actually initialize it. It's a plt.subplot subplots, and inside that into giving him how many row and the how many columns. So 2 row and the 5 columns, and into giving him a figure size. So let's say giving him a fixed size, and let's give it the fixed size called 20 comma let's say 10. Okay, fine. Okay, that's about my figure size. Now what I can do is simply going to iterate to um, all the axes. I mean, how many axes it have? It have the 5 axes. So you can creating here the enumerate. So which one giving me the index number as well as my axis, in whose axis I am going to plotting my images. So let's say enumerate. Let's enumerate, and inside that I can give in my axis dot flat. So this axis dot flat actually giving me the how many row and how many columns should be here. And now inside that I can taking it just like index number and also the axis number. So now we can check that if the I is nothing but the length of the image to be displayed, because we're simply going to display here the 10 images. So that's why I need to creating the subplot of the 2 cross 5, I mean row and the columns, and how many images should be displayed. 2 comma 5 is nothing but 10. So we need to passing here image to be displayed. That's why I already initializing these variables. Now inside that I can using here now mp image to show the images. So you can using here the mp image dot read, I am read, and inside that I can passing here my image to be display, and simply I need to passing here my I. So I is nothing but the index number. I mean which index number value is simply going to print it here. That's my images, so I can take it just like the image. And after that I can like that x dot I am show, and inside that I can passing here my images as well. I can also do my axis should be the off. Okay, so let's make it axis should be the off. Otherwise let's say if don't have any error, I mean it don't have any images inside this predict folder, so what it can do, just it can show the axis without the images. So let's say x dot axis, and inside that I can using here the off. Cool. Now we can finally say that plt dot tight layout, and after that I can using here plt dot show. That's it. Okay, plt dot title layout, and after that you can use the plt show. Okay, you can see it has no things called the length. Image to be display, images to display. Yeah, 10 images, but from where? 10 images from the images. Okay, 10 images from the images. So that's why you're taking the all of the images. Yeah, that's why you can see some error is happening. Now you can see here, shift enter. Yeah, because image is coming from the images folder, because yeah, that's the length of the images. Now you can see here the images is showing up in a 2 row and a 5 column. If you're trying to changing this one, let's say 20 images, so you need to changing this one like this way. Let's say 4 comma 5, I mean 4 row and the 5 column like that. So you can see just avoid it will try to creating the floating one. Okay, because it will loading the 20 images from the folder. Now you can see here in the each of the images it having the 4 row and the 5 are images, I mean 5 columns. Okay, and you can see how you detected the coins. So if I try to making it 10, so that we can see it clearly, so just to white, then you can see how it detecting the coins. Okay, it actually detecting the coin number. You can see coin number, it will detect the coin number. Let's say this is 10, you can see 10. Okay, that's me detect the coin number. Now the question is, sir, it will be better when you detect the full coin. Yeah, you can also do it the same thing. It's your task, but this is the uh, actual best one to detect, because in sometimes of coin in the coin the number is not actually visible in the other phases. I mean in the other case, let's say this is the whole coin, let's say 10 is visible. Now the opposite side or the head of the tail side, it not showing up this number, then this cases it's not detecting the numbers. So that's why I am choosing the detecting the number one, because I need to counting that how many rupees it have और how many पैसे it have, कितना पैसे यहाँ पर है, इसलिए तो मैंने इसको build किया ना. That's the technique to use, right? Just number, see how it will detect it here, and you can see it's not detected well. You can see it's not detected well, see, because it's not showing up. But if you giving here the full coin, obviously it not also be detected well. Sometimes it will give you some misinformations. Okay, just like 2 should be 3 or 5 should be 10, like that. Yeah, so we see in our whole method one coin is not detected. That's not a problem. How are you going to testing out, it will working fine. Well, so now what I can do is simply going to checking one new images. So let's try to upload it. What I can do is simply going to giving here on custom images, click on upload, and this is the images. Yeah, there is the images. Okay, so this is the images. I'm going to using it here for nothing but the predictions as well as counting. I mean how many images, sorry, how many coin it have. Okay, so what I can do first, I'm going to importing in the cb2. Let's say import the cb2. Then after that I can importing in the matplotlib. See, we detected the coin but we're not counting out. Now we're simply going to detect it as well as counting that how many rupees it have. Okay, कितना पैसा यहाँ पर है हमको टोटल करना पड़ेगा. ओके, लेट्स से मैटप्लॉटलिब थोड़ा ज़्यादा मैंने बकबक कर लिया शायद. ओके, डॉट pyplot splt. Then after that what I can do is simply going to import the collections. From collection I'm simply going to importing the counter. Counter is needed because you need to count them. You need to count that how many rupees have in the 2, how many rupees are for the 10, how many rupees for the 5. So that's why you input here the counter. So now let's say this is my image path. So let's say image path, that's my image path. Let's copy this one, copy path. And after that, I'm simply going to pass it here. Okay, that's my image path. Now what I can do, I'm simply going to pass it inside my predict function. So let's say model.predict, and inside I'm simply going to pass in here my image path as my source. So you need to giving here also source. as the parameter. Source is nothing but the image path. Now after that I need to give here my image size. So image size is nothing but 640 that you see in the GitHub repository for the Yolov10 as well. Okay. Now I need to give here the confidence score. Let's give here 25% confidence score. If it is greater than it is, if it is less than 25, it's not detected. That's mean in this case it's not detected because confidence score is nothing but the 25%. That's why it's not detected. Okay, it's not detected. Maybe the confidence score of this portion is nothing but 0.10%. Okay, but for machine learning cases, whether using here the 50% or up to 80%, it should be the better one. Okay. Now what I can do is simply going to giving here. Let's try to decrease this one. Confidence should be the 15 and try to also checking this one, but for that I need to running this shell also, but I don't think that I need to run it. You need to do it. It's your job to do it, right? Just you changing inside the your functions and try to change your confidence score, then hope so it will also detect it. Okay, now let's make it 50%. So that's my result. So let's make it result, not hereby, इधर पे देना है result. Okay, result. And after that what I can do, let's say using the annotated image, because you need to also taking the we also need to have the images. So annotated by annotated image. So it's simply going to take it from the my result. So result of the 0 dot plot. Okay, plot. Now let's try to using shift enter. Now you can see, just to white, you can see this my images, how many it have. So I think I can show it just like that if you want to show the annotations. So I just need to using here this annotations, annotated images, just to white. Then you can see the, yeah, it's right now you can see the annotated images should be look like it's nothing but one kind of array. But if you want to showing this one, so you need to actually using here your annotated from. So you need to using here, let's do it here. So let's say annotated image, and inside that I can giving here all of the row, all of the columns, then taking all of the images from the rest. Okay, so that's my images now. So now if I'm trying to showing these ones, then you can also show the images as well. Yeah, it's not showing up, just to wait, इसको delete करना पड़ेगा. Let's try to annotated images equal to all of the row, all of the column, and 2 and 1. So let's try to copy this one, I mean cut this ones, and try to showing this one here. So here, yeah, it's also images. So it's also rare, so you can using here pld.imshow so that it can convert them into the imshow also. Just a white, yeah. Now I think it should be printing the images as well. Yeah, now you can see here that's my images 1 5 1 5 2 10 1 2 2 1. Yeah, our image is detected well. I mean we can do it for the one by one images. So let's cut this down here, and I am simply going to paste it here. Yeah, it's take time. So you can see it will, as well as it, you can see here how many images it have. Okay, size of the images, you can see 1 and then 10, then 3, how many, you can see 4 ones, then 110. I mean just only have the one coin for the tens, 3 twos, and 2 fives. So all the things you can see the counting down. So that means the counting also stored inside this result variable. So we can also taking these ones from here. So what I can do, we need to just extract in that how many detected. Okay, so for that what I can do, how many detected. So you can say that detection is coming from here, result dot boxes. So result dot 0 dot boxes dot data. So you can get here my detections, I mean how many detection you have. So if I try to shift enter and try to printing this out, then you can see that's nothing but my detection is nothing but one tensor, that you can see detection is about tensors it have in the data. Now inside this data, what I need to do, I just need to pass it inside my model, and then we can get the number, exact number which one is detected. Yeah, samajh aaya? I think not. See, first what I can do, we simply going to predict it, and after that we can get here one result, and then we get here the annotated images, and we also showing the sound. Now we need to checking this how many boxes is detected. Then after that, inside this box says which class is detected. This is my detection. Now we got here our detection is a tensor. In a tensor, now what I can do is simply going to pass it inside my model. So let's say model dot names, and inside this model dot names, what we have, we have the detection score. Now inside the detection we have the class. We have the, see inside the detection we have the class. So what can do, we can take it, let's say for class in detection. Okay, detection. How many classes? Let's say we have 4 classes. So you can give it here 4. Okay, detections. You have the 4. Okay, we have the 4 classes. Now we're simply going to creating here our lambda functions. Sorry, anonymous call in a list comprehensions. And inside that, what I can do is simply going to taking all of the names and simply going to pass it inside the integers. So let's say int singular class. Okay, that's it, just a word class. Now inside this class, this class is nothing but my coin number 1, 2, 5, 10. That's mean it will taking all of the detections classes inside the detection bounding boxes and store it inside the list. So this is nothing but my class name. So let's say class names. That's my class names. Okay. Now if I try to printing these class names as well, just to write that you can see our class name is also showing up. Here you can see that's my class name. Okay. Now what we can do, if I try to making it, let's say 5, yeah, it's also work. See, if I using here the 5, it will show here 5, 1, 10, 1, 2, 4, 1, 5, 2, 2. Okay. Now if I using here the 4, just to write, see what happened. All of the things, I mean all of the values nothing but the 1, because our index number is starting from the 0th. That's why we need to using here 0 plus 1. That's mean, sorry, 0 starting from the 0 and at the 4. That's mean 4 plus 1 equal to 5. That's why we have the detection score is nothing but the 5. That's why we're giving it here, and we got here the class name. Now you can see 5, 1, 10, 1, 2, 1, 1, 5, 2, 2. So if I joining this list, then I can get how many total value are available inside this picture. I mean how many rupees, how many coin it have. Okay, yeah, we can also do one counter. So because we are already importing here the counter, so inside this counter, what I can do, it is simply going to passing here my class name. So let's say class names. Okay, so this is mathematical counter, so it will give me some count. Some count. So let's say count, right? So if I try to checking this count, just to wait, I need to close this one, and if I checking this count, then you can see counter is nothing but one counter dictionary. Now the 5 is nothing but 2, 1 is nothing but 4, 10 is nothing but 1, and 2 is nothing but 3. Key and the value. That's mean 5 are nothing but 2. I mean 2 coins are nothing but 5. 1, 2, 3. Kidhar. Sorry. 5 are nothing but 2. That's mean 1 and 2 are nothing but the 5, and 1 are 4. 1, 2, 3, and the 4. 4 are the coin for the 1. Then 10 is nothing but 1, and 3 is nothing but the 2 coin. So 3, if I stack this one, here is the 3. Oh, sorry, 2 coin is nothing but 3. Actually, yeah, it's if 1, 2, 3. That's when 3 are the coin for the 2. Okay, see again. See, 5 are nothing but 2, 1 and the 2 coins, and 1 is nothing but 4, 1, 2, 3, and the 4, and 10 is nothing but the 1. Here you go, and 2 is nothing but 3, 1, 2, and the 3. Now our counting is done. Now what I can do, we're simply going to sum it up. So how can you sum it out? We can using here the, let's say, sum of the values. So it's better we can creating here only, so that it can also showing up rupees value. So what I can do, we can, let's say, yeah, it's also a dictionary. We can also taking it from the counter as well. Okay, but let's say rupees values is not just creating one dictionary. See what actually happened. For the 1, we have the 1, because this is also nothing but one string classes. Okay, string class. That's why simply going to convert it into the integer. So inside that we have the 2 is nothing but the 2. Okay, let's say for the 3, I think 3, we don't have the 3 rupees. So for the 5 we have the 5, and for the 10 we have the, should be the 10th. Okay, so that's nothing but a mapping for the rupees value. Now we get in the sum of that. So let's say rupees value, and inside this rupees value, what I can do is simply going to giving here my name. That's my name. Okay, so this name is coming from the counter item. So what I can do, we're simply going to check it. Let's say for name and the count. Okay, in count dot item item C. Why actually? See, if I see the dictionary, this is nothing but one string. Okay, this 2 and the 10 and the 1 and the 5 is nothing but the dictionary. So what you can do is simply going to creating one list, sorry, dictionary for that, and try to convert them with the key value pair should be the 1 2 like that. That's mean if we got here the 1, then we're simply going to convert them in integer of the 1. I mean, we're going to take in the value for that. Now inside this count dot item, I have one name and also as well as my count. So what I can do is simply going to passing here my names, and I am simply going to making this into with the counts. Then we can get here the sum of the rupees. So if I, let's say total total value, then you can get here the sum, total sum of the rupees. So let's say this is nothing but the total values is nothing but the 30. So let's say if I checking this one, 1 5 6 7 7 5 12 13 23 25, then 25 27 29 30. Yeah, total value is right now 30. This is how the sum is working. See again, first you input the CB2, then also input the matplotlib, so that we can showing these images. Then also import the collections. From collection input the counter, then giving here my image path. This is the custom images. Then we simply going to using here the model.predict and giving here my image size as well as the confidence score. Then we simply going to showing this one using the pld.imshow, and after that we can get in this bounding boxes data, just getting the bounding box data. And after that, inside these bounding boxes, you need to taking that which one is the class name. Now we also extract here the class name. Then after that, you can pass this class name inside a counter so that we can also counting these ones. And after that, we're simply going to creating one dictionary for the string to the integer so that we can also understand this one. And after that, we can taking all of the values from the each item. And after that, we're simply going to creating here one sum method. And inside the sum method, we're simply going to do the multiplication for all of them. So this is nothing but my total value. Now if I try to check if you are not using here the detection string just for sajane ke liye, so you can also using this technique. So let's say comma, and I am going to using a total number of values and try to begin to join this one so that we can showing this on the how many of the coin of the 1 and how many coin of the for the 5 and how many coin for the 10s. So what I can do, we can simply going to creating here on f string. So let's say f string. So we can say that nothing but names. It's nothing but my name. Okay. Then also the count. So we can making it count. So for name count in count dot items. Okay. So that's my name and count is coming from here. Okay, now if I try to showing this one, this is not my detection string. So let's say detection string, and now if I try to showing this one, just to write detection score, so detection string, then you can see how the detection string look like that. Okay, that's are nothing but the 2 1 for the 4 and 10 for the 1 and 2 for the 3. I mean, how many rupees it have? So 5 rupees is nothing but the 2 coins. For 1 4 coins, for 10 1 coin, for 2 3 coins, and sum of is nothing but the 30. Okay, so now what you can do is simply going to giving here one print statement. That's called detection string as well as the total count. So total count, total values, you can say like that, total values like that. Yeah, now you can see total values is nothing but 13, and those are the detection string, I mean count. Okay, so now what you can do is simply going to creating here a web applications using the Gradio library. So So for that, and also installing here the Gradio. So let's say pip install Gradio. Yeah, it will installing the library called Gradio. Now what I can do is simply going to import it here. Let's say import Gradio as gr gr, and after that I need to importing here the cb2. Let's say import here the cb2, and after that I'm going to importing here the numpy. Because when I upload the images, we need to upload the images just like the numpy file. The type of the image should be the numpy, and also importing the collections. So from collections, I'm going to importing here the counter. Then I'm going to creating here a functions called predict which one taking one image. So image, and how an image is coming up, then I'm simply going to convert them into the RGB. So for that, you're going to using here CBT color, and after that I need to using here CBT color and using here the image. Okay, using here the image. It should be a CB, not CBT color, then image, and after that this taking the images, we're simply going to giving here my color code. Let's say cb2.color bgr2 rgb, and after that this is my RGB images called image rgb, and I am simply going to copy the code from here. Here I go, yes, this one. So I'm simply copying in these ones, just these ones. Here you go, and after that I'm simply going to paste it here. Okay, so I need to also do some indentations. plt.show, yeah, I don't think the plt.show is not needed yet. Then this one, this one, this one, as well as these ones, we need the total values, the detection strings, as well we also need the annotated images. So what I can do is simply going to copy these ones, and I'm going to using here these ones, and I'm going to copy the annotated one. So this is nothing but my plt.show. So you can copy these ones because you need also showing up in our Gradio library. So I'm simply going to make it out. Now inside that, what I can return, I just simply going to return here first annotated images that you're going to show. Then after that, what I can do, I am simply going to passing here my detection string. So detection string, so that we can show it in our application as well. Then the total value, so total value. Okay, fine. So that's nothing but my functions called predict functions. Now I am simply going to creating the interface using the Gradio library. So let's creating this one. So gr.interface, and inside that I'm going to passing here my predict these functions, and let's giving here inputs. So it will take in the inputs. Let's say gr.image, and inside that it will take in the image in the form of the numpy. So let's say type is nothing but numpy format. It will taking these ones, and you can giving here one label call, let's upload an image. Okay, that's cool. Now what I can do is simply going to also store here inside the outputs. So let's say in the output we can using a zr.image. You need to also show the images with the detections. So let's say you need to giving a type equal to nothing but numpy type, and then you can also giving here one label called, let's say, annotated image. Okay, now we need to also showing up two things in the output called gr.textbox. Inside this text box we have the first text box is nothing but for the detection string. So where can the detection, okay, detections, detection count, I mean how many detections. Then after that you can say that the total count. So let's say gr.textbox, okay, text box, and inside that you can giving here my text box labels is nothing but you can also giving it like that, labels is equal to detection count, and inside that you can say that this is nothing but a total sum, or you can say total rupees like that. Okay, let's making it inside the labels. So let's say this is the labels. Yeah, that's my total rupees. Now what I can do, I am simply going to Also giving here the description as well, and as well as the title. So let's giving here the title is nothing but the Indian coin count and detections. Okay, so what I can do, we can also giving here on descriptions. So let's giving here description. So what I can do, let's say giving here comma, then let's say just an instruction, let's upload an image, and the Yolov10 model will detect and count the coin. Okay, that's our thing. Now what I can do is simply going to launch our applications. Okay, so we can make it inside a variable called app, and we can launch our application. Nice, app.launch. Yeah. Okay, now let's wait for a few seconds and it will try to load in the model as well as here. So got exotic keyword called labels. Init got and uh, levels or label. It should be level. So actually giving here levels. So that's why this kind of errors. Yeah, let's try to run it again and try to checking this one. Yeah, you can see this my public URL. You can also using your mobile phone to testing it out. You can share with them. So let's clicking on this link and it will opening this one. Just to wait. So click and drag and drop the images. So I'm going to dropping these images as well, and I'm going to clicking on the submit button. But before that, let's try to load it out. Submit, and now you can see here that's my annotated images. And detection is nothing but 5 equal to 2, 1 equal to 4, 10 equal to 1, and 2 equal to 3, and total rupees is nothing but 30 rupees. So this is how it will actually work. Yeah, Indian coin count and detections. So that's it for today now, and hope you enjoyed this tutorial, and make sure to subscribe to the channels and don't forget to hit the bell icons, and I'll be back with another tutorial. So till then, take care and bye bye.